All right, so today we're going to go ahead and start reviewing with our beautiful semester final or study guide for our final. We're going to start with the first one. And as you guys see, what type of parent function should I have here? It's a quadratic. Notice here that it looks like a parabola, and we have a highest degree of true. Now, our question says that we need to write the domain and range. Do we know how to do that? I hope so. Of the function as an inequality, using notation, set notation, and then using interval notation. So we're going to go ahead and start first with our beautiful inequality so we can go ahead and identify what the parts are, okay? Also, we're going to go ahead and describe the end behavior of the function and explain if there's no end behavior or if there is, okay? I'll go ahead and go into a little more detail just so I can refresh our memories on that. Now, for the first part, we're going to go ahead and start with that inequality. So let's start with the domain. Okay. Now, domain were all what type of values? All of what? All of our x values. So we're going to go ahead and look at all of our possible x values. So what do you guys think? What's my domain here? If I were to select, for example, -1, do I have a y value for it? -2. What about -3? It looks like it's -5 or down below. What if I were to pick, let's say -5 over here for x? Would there be a y value for it? Even though we don't have enough, the graph is not long enough, we would have another value. Notice that the arrows would indicate that our values keep on going on and on and on and on. So our domain goes from what? -infinity, and it goes all the way to in our x direction. So let's say if I pick 1. Okay, now we have a beautiful domain, right? We have all the x values. No matter how far we go on to our negative values, we have a matching negative value over here. So it goes from -infinity. What if I go to the positive infinity? Do we have a matching y value to it? Yes, so it goes all the way to positive infinity. So our x value is going to be somewhere in between. Can it equal a -infinity? No, so we're just going to make sure that we write that it's going to be greater than, or x is going to be greater than -infinity. And it's also going to be less than positive infinity. So this is our inequality. Now, my set notation, very similar, except we have to define our variable. So remember our curly brackets? So we do our curly bracket. We're going to go ahead and make sure that we write our variable. This time we have x, and it comes from -infinity. X is somewhere in between, and it goes all the way to positive infinity. And then we close our beautiful curly bracket. Now, how do we write it in interval notation? Using our brackets or parentheses. Do you guys remember? Parentheses. We have it from -infinity, always the lowest point, all the way to positive infinity. And bracket or parentheses. Parentheses, remember that it cannot equal infinity. We never enclose that up. Notation. Okay. All right. So that was domain. Range. Range includes what values? The y value. So we're going to go ahead and look up and down. So in this case, our lowest point is what? We have arrows. -infinity because it's all the way to the bottom. So -infinity. And it goes all the way up to 3. 3 is our beautiful highest point. Okay, so my range, it comes from -infinity. We always start from the lowest. And it always, or it ends up to being, or it stops at 3. So my x value is going to be somewhere in between. So x is going to be greater than -infinity, but it's going to be less than beautiful 3. So how do we write our beautiful range in set notation? Our curly bracket, what variable are we using? Y, such that our values are in between negative infinity. This time, and it's not X, it's Y. And all the way up to beautiful 3. Can it equal 3? Yes, it can equal 3. So make sure that we state that we have 3 included in our set. Now, what about interval notation? Parentheses, negative infinity, all the way up to positive 3. Can we include 3? It's a bracket. Yes, we include 3. Woo-hoo. Not too bad, huh? All right. Now our beautiful end behavior. Now our end behavior, guys, we look at what's happening when we focus in the X direction and what happens to our Y value or f of X value. Remember that our f of X is the same as stating that we have Y. So let's go ahead and state or focus first as X approaches positive infinity. So positive infinity meaning that as it goes this direction, in the X value, what happens to my Y values? What direction do they go? They go down. So all my values are going to start approaching down. So therefore, my Y values are going to be in the negative infinity. Okay. Now, what if we look at the other direction? Let's go ahead and see if it goes now to the negative infinity for X values. So if, as X approaches negative infinity, what happens to my Y values? If I keep on going this way and this way and this way, what happens to my Y values? It keeps on going down. So my Y values go to the negative infinity as well. So that's just stating what happens to them. Now let's go ahead and see another example. Let me see. What if I had a graph that looked like this? Here's my beautiful graph. Here's my function. It goes up this way and it goes up down this way. Now let's see. If I were to look at my positive X values and I look at infinity, what happens to my Y's as X approaches positive infinity? It goes up. So my Y's approach positive infinity. What if I were to look at the opposite direction? So what if I look at now where my X values go in the negative infinity? What happens to my Y values? They go down. So my Y values go to the negative infinity. So very similar, but yet different. We have to look at what it's matching and where they go in each direction. Yes. It would both be approaching the positive infinities. So negative or positive, they all go positive infinity in the Y's. Very similarly. Okay. Any questions on this one? No, not too bad, huh? Okay. All right. Everybody have that? No? There. Ready? 3, 2, 1. Drew. Thank you for taking notes. Thank you. All right. Let me clear. Let's move on. Listo? Jesus? Yeah. Okay. All right. Let's go ahead and move on to number 2. Let me zoom out a little bit so we can see. Perfect. All right. Number 2 is going to model fireworks. So you guys know how fireworks work, right? You guys have seen it, right? 4th of July. So they go, they explode, and then they come back down, right? So right here it says a firework projectile is launched at 20 meters per second. So they already give us a rate from a 60-meter cliff. It says the table shows the height in Y in meters. The projectile is above a field after X seconds. So we're going to go ahead and look at what we have here. We have a given table. First point or first item that we are asked to do is to plot the points on our beautiful graph. So let's go ahead and plot our points. My first one says that I'm going to go ahead and start at 0 seconds, and its initial height is going to be 60 meters. So which one represents my time? Which axis? The x-axis. And by default, my y represents my beautiful height. So at 0 seconds, I have a height of 60 meters. What is my next height on second number 1? 75. So I'm going to go ahead and go on to the first second, and I'm going to mark 75. So it's going by tens. So this is 70 and 5. Right in between 70 and 80. Next one we have 2 and 80. Next one we have second 3 is what? 75. 4 is at 60 meters. And at 5 seconds, it's now at 35. So here's 30 and 35. So let's go ahead and create our beautiful curve. From here to here to here and all the way down. Awesome. Okay. Now we plotted our beautiful points and we marked our beautiful curve. Now, we don't need more points because obviously we're just looking at that piece of the trajectory of the fireworks. After that, they disappear. So the same thing as whenever you throw something, you throw it and then it comes back down. So our second point is going to ask us, what is the maximum height of the projectile? 80. So we're going to go ahead and look at the height. Its height is 80 and it happened at what second? After 2 seconds. So it's 80 meters. And it happened at 2 seconds. Okay. Now, it's asking us over what interval is the projectile's height increasing? So how can you tell if a projectile or something is increasing? It goes up, right? Its slope is up. So let's go ahead and see. If we already know it reaches maximum height at 80, what do we know, or how do we know throughout what intervals it's increasing? Let's go ahead and see. What did we start with? We started at 60 and it went all the way to 80. So between what times? 0 and 2. So we're going to go ahead and see between 0 and 2 seconds. It increased and it was from 60 and it went all the way up to beautiful 80 meters. All right. So this is increasing. Now, our second question is, over what interval is the projectile's height decreasing? So how do you know if it's decreasing? It's going down. All right, so which part does it go down? From 2 to 5. So from second 2 all the way to 5. And its height was what? From 80 and it went all the way to 35. Not too bad. How do you feel about these? Not too bad? Okay, so this is just interpreting our beautiful data. Okay. Next page. I love this one because we've been doing this. All right, so number 3, describe how a transformation of how to transform the graph f of x equals x squared to obtain the graph of the function g of x equals 2 times f of x plus 2 squared minus 3. Then draw your beautiful g of x, okay? So yesterday we went over the combinations of all of our graphs all together. Can we identify the parameters here? Yes, what's one, Charlotte? Okay. A, which one's A? Oh. Which is, when is A? Or what is A? 2. Did you say A or K? K, okay, tell me K. Ay, Dios mío. A equals what? There you go. Charlie, pass it on. Julio, help me identify another one. Here, let me go ahead and write it for you guys in the general form. G of X, we did this one yesterday, equals A times our beautiful F of X, inside parentheses, X minus H, plus beautiful K. Which one's another one?
H.
H, which one's H? Yeah, so what is H if you take it out of the function? He has it. He has it.
I think I have it, but no.
A ver, what is it, Julio? A ver, Carmen, help him out. It would be -2. It is 2 inside of the equation, but remember, whenever we take it out, it's going to be the opposite value of it. All right, the last one. What is K, guys? K is -3. All right. So what does A do? It shrinks it or it stretches it out. So we're gonna go ahead and make sure that we shrink or compress it first. What does H do? Moves it left or right. So what is it going to be, left or right? It's negative outside, inside is positive. So remember that it's always the opposite of this. So what is it? Left. So it's gonna be 2 to the left. What about K? What does K do? Up and down, and it's negative, so we're going down. How many steps? 3 down. So this one is going left 2, and this is going 3 down. Now we need to do A first. So remember, we have to create our little table, or basically find what our A of X is first. So we can go ahead and identify what our values are first, so the transformation, and then identify what the parent is. So I'm going to go ahead and create my table so I can organize my work. So first of all, I want to write my domain. What domain do I want to use? -2, -1, 0, 1, and 2. And let's go ahead and create my F of X values, just so I know what they are. So what's my parent function? X squared. So what is my F of X value? So it's -2 squared, 4, -1 squared, 1, 0 squared, 1 squared, and 2 squared, 4. Okay, let me go ahead and graph it just so you guys can see what the parent function is. Here's 0, 0, 1, 1, 2, 4. The same with 1, 1, and 2, 4. Whee! Okay, this is F of X. Just so you guys know. All right, now let's go ahead and do the A of X. A times F of X. What is my A? 2. It's my first case. I need to multiply all of my F of X values by 2. So what are my F of X values? 4. 4 times 2 is 8. 1. 1 times 2 is 2. 0. 0 times 2 is 0. 1. 1 times 2 is 2. And 4. 4 times 2 is beautiful 8. All right, let's go ahead and graph this one so we can see what it looks like now. At -2, it is 8. It goes outside of our graph. So let me go ahead and graph it up here. At -1, it is 2. At 0, it is 0. At 1, it is 2. And the last one, 2, it is beautiful 8. So it's out here. So here's my beautiful graph. Perfect. Now from here, we have to what? Move it 2 to the left and 3 down. So let's go ahead and do the first one. I'm gonna go ahead and do this one in green. 2 to the left. So I'm gonna start with this one. 1 and 2. And then 3 down. 1, 2, and 3. So here's my last point. My next point. 1, 2, and 3, and then 2 down. 1, 2. Sorry, I did it backwards. Sorry, guys. Thank you. You guys are paying attention. 1, 2, and then 3 down. 1, 2, and beautiful 3. Let me repeat that process one more time. 1 and 2, and 3 down. 1, 2, and 3. Let's go ahead and move the last 2 points up here. 1, 2, and 3. No, 2. Goodness gracious, I don't know why I keep on putting 3. And then 3 down. 1, 2, and 3. Last point. 1, 2, and 3 down. 1, 2, and beautiful 3. All right, so here are my points. Connect your beautiful graph, nice and beautifully done. And we're able to identify the rest. Once you have all that, you can go ahead and delete the rest of the parts. You don't need your other parts. There it is. Your blue graph is your new graph, your G of X. Now, in order for us to write, or it's already written, we need to write it down. How do you feel about these? Yes, Charlie. We only need the blue graph. I used the original, the parent function, and then the a f of x, which is in red, just so I can go ahead and then shift it. My parent function basically establishes, or it tells me which of the functions I'm going to have. And then from there, I know what it's going to look like afterwards. So it's just basically like guiding me how my function is going to look like after I've been transforming it. Okay, how do you feel about these now? Okay, let's go ahead and move on to number 4. Do you guys want to do this one on your own? A ver, try this one on your own. Let's see what you guys get. It says, given the graph f of x equals x to the power of 3, graph the new translation of 3 steps to the left and 2 up, and write the new transformed function. So include the transformation, the function that has been transformed into, okay? So I'll give you guys a couple minutes to go do it. A ver. Given that the graph of f of x equals x to the power of 3, we have already the beautiful parent function graph. What type of function is it? It's cubic, right? So we have it to the power of 3. Now we have to graph a translation of, what's our first translation? 3 steps to the left. Automatically, which parameter do we have that moves to the left or right? A, H, or K? H in this case. So we know that this one's going to be H. Now, the next transformation is what? 2 units up. Which parameter moves up or down? K. So which parameters do we only have here present? H and K. All right. So we know that we have G of X. Let me write it in black so you guys can see it. G of X equals, we don't have A present, so I'm not going to include A. I'm just going to include F of X minus H. Now it is to the power of 3, so I have to make sure that I write 3 as my beautiful power. And I am adding K. Yes. So I'm going to go ahead and identify what they are right now. So H, we're moving it to the left. So therefore, it's what? It's going to be positive in the formula, but once we identify it here, it's going to be -3. Our beautiful K, it's 2 steps up, so it's positive, true. So here we're gonna go ahead and substitute, and it's going to be positive 2. Here we're substituting, and it's going to be -3. Now, the way that we're writing this is g of x equals, instead of writing f of x and everything else, we're just writing x minus our beautiful h, which is -3 to the power of 3. And we're adding beautiful 2. Okay, all right. G of x equals x. What happens to my negative and my negative? It becomes a positive, so we now have +3 to the power of 3. And we now have +2. Raise your hand if you got that as a beautiful equation. Woo-hoo. Let's go. All right, let's go ahead and translate now my beautiful graph. Our parent function is already done for us. Which one do you guys want to do first, left or right? Left. So we're moving those to the left 3 spaces. So 1, 2, 3. 1, 2, and 3. And last one, 1, 2, and beautiful 3. And now we're going up to 1 and 2, 1 and 2, 1 and beautiful 2. And those are where my beautiful g of x points are. It looks like a linear, but it's not, remember? It's a cubic. Nice and beautiful. This is our g of x. Raise your hand if you got that as your graph. Awesome. Okay. Go ahead and save an image. Everybody has that? Okay, perfect. All right. The next one, guys, I'm going to go ahead and take that one out. So I haven't gone over this lesson. It will take me a whole entire day to go over this, guys. So inverse functions, that's what we're going to go ahead and start with when we return. I'm taking that one out. So go ahead and cross this one out. That's going to be part of second semester kind of. Okay. Number 6. Now we've done some inequalities, guys. Or not inequalities, absolute values. But we haven't done like this in depth, but very similar to what we've already known on how to solve for x. Let me go to show you guys how. Now, our example number 6 is asking us to isolate the absolute value expressions in the following equations to determine if they should be solved or can be solved. Now, if so, we're going to go ahead and find the graph and the solutions. If not, we write no solutions. Now, the reason or the only way that an absolute value can be solved is if whenever we have our absolute value, we have our variable inside and its outcome is going to be a positive value. Right? Remember that anything that's coming out of our beautiful absolute value is always going to be positive, right? We did our parent function with that. Now, if at any moment, let me go ahead and write a squiggly line. We have our absolute value of x and its result is that negative value. In this particular situation, there's no solution. And the reason being is that because whenever we have anything inside of our absolute value, it must be positive when it comes out. Therefore, it doesn't exist when it's negative, okay? So let's go ahead and determine and see if we can solve it or not. So we have -8 is being multiplied by my beautiful absolute value of negative x minus 6. We're adding 10 to it, and it has to be equal to 2. So we're going to act as if my absolute value is a variable, right? We're going to go ahead and isolate it so that we can go ahead and see what its result is. See if it's positive, then we can solve it. If it's negative, then it's no solution. All right, so what's happening to my absolute value? I'm adding 10 and multiplying it by -8. So inverse operations, very similarly. Subtract 10 on both sides. We're left with -8 inside my absolute value, negative x minus 6 equals now what is 2 minus 10? -8. Now, we're not done isolating. We still have one more step. It's multiplying by -8, so we have to divide both sides by -8. So let's go ahead and divide by -8. Our intention is to eliminate that beautiful value outside of our absolute value. And we now have absolute value of -x minus x minus 6 equals, what is -8 divided by -8? Beautiful one. Is our solution a positive value? Yes. Can we solve it? Yes. Okay. Now, let me go ahead and create some space. Since we can solve it, the way that we're going to do this is that we're going to go ahead and think about it as if it were a square root, where it has two possible solutions. It has a negative solution and it has a positive solution. So let's go ahead and see. We have -x minus 6 equals +1. This is my positive solution. And my second solution is -x minus 6 equals -1. So whatever we put in here, it's either going to be a -1 or a +1, because whatever comes out from an absolute value, it's always going to be positive. Okay. All right, so let's go ahead and solve my first equation here. How do I solve for x? Add 6. And then I have -x equals 7. Then divide by -1. We have x equals -7. That's my first solution for x. All right, my second is whenever I have -1 as a result. So let's go ahead and add 6. We have -x equals -1 plus 6, +5, and then divide by -1. So therefore, x equals -5. Woo-hoo. And then the reason, or the way that we graph them, is that we look at a number line. We're just going to look at -7 right here. Here's -7 and -5 right here. They're just going to be two values that are going to be part of our beautiful sets. So this set only has two values. Okay. How do you feel about these guys? Let me give you guys one to practice on your own. Ready?
No.
Yeah, that's why I said you can go ahead and work on it at home, but I'm still going to go over the examples in class. And then you can come back and check your work to see if you did it. So tomorrow I'm going to let you guys work on it independently, and then on Wednesday, no, when tomorrow's Wednesday, Thursday, I'll go ahead and review it with it. I'll start from number 7, because I'm going to give you guys another example like this one. All right, let's see if we got it. All right, everybody has this? Perfect. Let me give you guys an example. Let me go ahead and clear. You can do this as side work, guys. Somewhere where you guys can have some space. Go ahead and try this one on your own. Let's see what you guys get. Go ahead and try this one first. Absolute value of 5x plus 5 equals 45. See if it has a solution or not first, and then solve for it if it has a solution. And my second example, let's see if we can do this one. 5 minus 8, absolute value of -2n. Or let's go ahead and use x. X, there you go. Equals -75. Let's see if we can do those two. All right. So the first one, who went last?
Me?
Julio, a ver, pass it on, Julio. Okay, Jesus? A ver, Jesus. So we have absolute value of 5x plus 5 equals 45. So we're trying to isolate the absolute value. Imagine that this is like untouchable
Okay.
for right now. We don't touch it. We leave it by itself. So everything that's directly outside of it is what we need to do the inverse operations of. So what is happening to the absolute value? We are adding 5, so we're going to subtract 45. We're going to subtract -5 or subtract 5 to 45. All right. So now we're left with absolute value of 5x equals beautiful 40. Now, can we solve it, guys? It is possible because it's positive 40. So therefore, we're going to go ahead and have our two answers, right? One's going to be the positive answer and the other one's going to be the negative answer. So now we have 5x equals positive 40, 5x equals negative 40. All right. Now, what do we have here? One step equation. X equals positive 8 over here. Negative 8. Woohoo, Charlie. Yeah, you can put them together if you want to. You can write them together. 8 and positive 8. You can do plus or minus. It's very similar to when we're doing the square root that we have two possible answers. So basically we're doing the same, not the same principle, but the same idea that there's two possible answers here. All right, let's go ahead and look at number 2. What's happening to my beautiful absolute value? Remember that we are going to act as if it were a whole complete variable. We don't touch it. What's happening to it outside? It's multiplying by negative 8 and what else? What about the 5? It's positive, so it's what? Adding 5. So how do we get rid of that beautiful 5? So let's go ahead and subtract 5. It's written in the front of the same thing as if it were to written afterwards. Okay, so we have negative 8, absolute value of negative 2x equals negative 75 minus 5, negative 80. Last step, divide by 8, divide by negative 8. We're left with positive 10. All right, can we solve for this one? Yes, we can. Let's go ahead and see. Positive and negative. So negative 2x equals 10 and negative 2x equals negative 10. All right, so what's my solution for the first part? X equals negative 5 and positive 5. Raise your hand if you got that. Woohoo. All right. I'm gonna go ahead and stop it here, guys. Tomorrow, you guys can go ahead and work on from number 7 and on. And then when I return on Thursday, we'll continue with our beautiful study guide.